Okay, so I'll start now. So welcome to lesson one for the ordinary level refresher course. So today I'm going to talk about factorizing quadratics, okay? Or factorizing, but factorizing in general, and then factorizing quadratics. So it's a topic you might already be sort of familiar with it, but the purpose of this course is to sort of like, it's not supposed to give you necessarily new information. It's just to sort of get you back into the swing of things just before you start back into school. Okay, so if you want to say anything, just put your message into the chat. So you can just find your chat. I'll see it straight away. It's no problem. And also I have this little, so I may ask you some questions at some point, and I'll bring up this slide here. So what you can do is if I bring this up and I ask you for like we take a kind of a poll or something, for example, I might ask, yes or no to a question, then you can just scan this QR code. It'll come up on your phone and just like go into the box, or where is it? And like put an X somewhere in the box or something like that. Like we may not do this, but feedback is kind of good, in these lessons, right? So so either put your questions into the chat, or we'll be using this thing here. So the first thing I want to ask you is, when we say factorize, like what do you actually kind of think about? So with factorizing, like what we're doing is we're taking a number and we're sort of breaking it down into a bunch of like smaller numbers that we can sort of multiply together. So that could be something like, we could take the number 8 and we could say 8 is the same as 2 like multiplied by 4, or we could write that as, 2 by 4 like this, right? Or, that's one way. But another way is our number could be something different. Our number could be something like this. Okay. Now you might say, okay, 8 is a number. This thing here is an expression. It's an algebraic sort of expression or something like this. That it's not a number. It is also a number. It can be more than one thing at the same time, right? So this thing here is when we break this one down, we do this step called factorizing, where we break it down into two things that multiply to give us back. So we're taking numbers, we're taking things and we're breaking them down into smaller things that multiply to give us back the original. So we could multiply this back out here to give us 8, or we could multiply this back out here by multiplying that by that, that by that, this by this by this. So we do the first step, it's x squared. The second step, it's 3x. The next step, it's 2x. And the next step is 2 by 3 is going to be 6. So that's going to be x squared plus 5x plus 6. And we see we get back to the start again, okay? Now, a question might come up like, when we factorize something, are we done? And really the question is, are we done? The real question is, could we go further? Like for this one here, we could say, yeah, we could go further. This could be 2 by 2 by 2. I'm just using brackets because I don't really like writing down this multiplication signs because we get them mixed up with our x's, right? So now we can't go further. In this case, as soon as we hit the prime numbers, we can't go any further. Like we could take like any number, like let's take 72. Okay, so 72 is like 8 times 9. Then 8 is like 2 times 2 times 2 times 2, and 9 is 3 times 3. Now we stop because we can't go further. Okay. Now for this one here, we can't go, once you hit these linears, you can't go further than that. You can't break this one down any further, right? So that's why we're stopping at that point. So, when you're breaking things down, the question is like, when do you stop breaking them down? Okay. So that's a good question. But you'll kind of see that there's a good grounds to stop, basically. All right, so we have an example of a few different ones here. One of these is incorrect. Let's see if this works. Anybody want to try? Let's say the first row corresponds to the first one. The second row corresponds to the second one. The third one corresponds to the third one. Any of these jump out at you as being incorrect. Give you a moment. So if you wanted to do it, you can scan the thing, and it's a bit awkward. There are other tools you can use to do this, but I don't find them so useful. Well, the one that doesn't work is going to be this one. Okay, the rest of them are fine, but this one, you see, we've got x squared minus 9. So this type is the difference of two squares. And when we do the difference of two squares, this x here and this x here, they have to multiply and give us the x squared. But these two numbers here do not multiply to give us the minus 9. Okay, so now we can go ahead and multiply that out. I'm going to go ahead and multiply that out. So we have x times x, x times 9, 9 times x, 9 times. So this will be equal to x squared plus 9x plus 9x plus 81. Okay, and that's x squared plus 18x plus 81. So this is clearly wrong. But you don't need to do all that work, is what I'm saying. You see, this 9 here, it seems kind of correct because you see a 9 on this side, you see a 9 on this side. It's an equation. You think, okay, that 9 is 9, but actually in the context, this would have to be a +3 and a -3 to work. So there's some things that can kind of jump out at you just like that, without having to do all the work. It's just it's kind of like a loose thread, and you're like, no, that doesn't make sense. That's something out of place. If you want to prove that something's wrong, you just have to show one thing about it that's wrong. If you want to prove that something's right, you have to show everything about it is right. Okay, so that's why we just wanted to see if we could spot something that was incorrect. When you do maths, you're going to have to review your work. So when you're doing the exam and you've done a question, at the end, you're going to have to look at your question and go, is that right? And you would want it something like that doesn't make any sense. You want to have that instinct, build that up. Okay, so when we're factorizing, we're going to be having basically questions of 3 different types. Okay, so the first one will be ones like 2x plus 4. And you're going to be looking at the two numbers and looking for a common factor. In this case, the common factor is a 2. Now, we could have like x squared plus 2x, which kind of looks like a quadratic, but it's not because it doesn't have that small number. And we could also have x squared minus 2x, which kind of, or maybe let's say minus 4x. And this kind of looks like the difference of two squares, but it's not because it has that x there, okay? So this one here, the common factor is x into x minus 4, x into x plus 2, you see? Okay, so now this one here, let's say x squared minus 4. Now, this is one that's a good candidate to be the difference of two squares, is because we have the first term is an x squared term, something squared, like normally like a variable like x or y or something like that. And the second one, there's a minus sign, and then there's a number. And there's that number something squared. Well, here it is x squared minus 2 squared. And then you see, once we have something squared minus something squared, we take brackets like this, the first thing and the second thing, the first thing and the second thing, a minus and a plus. And it's just a quick way to factorize ones that are like that. So first of all, looking for a common factor. Second of all, and it might happen that you get mixes of the two. And then the last one, the trinomial, you're going to have ones where a is not equal to 1, obviously on the course, but something like x squared plus 5x plus 6, where you have the x squared term, the x term, and the number, okay? So when we factorize, so this is what I'm talking about, we either have these 3 cases, so we're either going to have to find a common factor, take that out, look for the difference of two squares, or it's going to be the trinomial pattern, in which case we have to do brackets and factorize out like we did before. Okay. So let's just go through a few very, very simple examples. The first one is that first type. So that's going to be, what's the common factor? 2 is the common factor. We take that outside brackets, 2x plus 3. Now, the second one is a little bit kind of trickier. And you see that the presence of the minus sign maybe kind of messes us up here a little bit. And something that I want to get you really, really used to is the idea of taking the minus sign outside brackets. So last time I took the 2 outside brackets. This time I'm going to take the -2 outside brackets. -2, open brackets, x. Now, -2 goes into 6 -3 times. So you see what I'm saying? This +6 is made up of, well, it could be 2 by 3, right? But it's also -2, sorry, -2 by -3, okay? And it's just a little trick. We basically, you see, suddenly a minus sign pops in where there was a plus, basically. So always taking a minus sign outside brackets, just check if you're right. -2 by the x is -2x. -2 by the -3 is a plus. -2 by -3 is plus. And then 6. Okay, so that's one thing that comes up. This one, x squared minus 16. Well, this is great because it's going to be like x squared minus 4 squared. So it's, if we have the x squared, we have the second number squared. We can see that this is a perfect square. So we're going to have like the first 2 sets of brackets, like the first thing and the second thing, the first thing and the second thing, like not squared anymore in here, and then a minus, and then a plus. And then we have, so now it's done. Now we can't go any further. X squared plus 7x plus 12. So this is a trinomial because we have, there isn't going to be a common factor. This is not the difference of 2 squares. So what we're going to do is we're going to say, well, let's look at this first number, 2 numbers that we place here and here. Remember, when we multiply out sets of brackets like this, and we have a number here, and we have a number here, and a number here, and a number here. So when we have that, it's going to be the first one by the first one. So this one by this one. Then the first one by the second one, the second one by the first one, and the second one by the second one. Okay, so the first one by the first one is just, that's going to give you the x squared stuff, right? Because, you know, so that's x and x. So that's got no numbers multiplying in. So it's just a pure x business just multiplying together. So that's that first arc. And the second number is going to be this second arc here. It's just going to be pure number, okay? So it's just something to, that's what, and then the other 2 are going to be the mixed terms when it's like an x by a number and a number by an x. So we have, what numbers can we get here to give me the x squared? It's just the x and the x. And then for here, it's 1 and 12, or it's 1 and 12, 2 and 6, or 3 and 4. Now, I know that you know this stuff already, but this is just warm-up type stuff for you guys for going back. And, you know, it's actually kind of interesting. Sometimes if you hear a slightly different way, someone explains something in a slightly different way, actually you have a different perspective and you're like, oh yeah, actually, yeah, maybe I was making that a bit more difficult than it really was. Okay, so what we're going to do now is we're just going to put in the 1 and the 12, and I'm going to have, so we have x by x will be x squared, 1 by 12 will be 12. So that would work for that one and that one. But what about the middle number? And really what we have to do is we have to take the sum of these two. So it's going to be x times 12, and so it's going to be a 12 and a 1. And we can't get the 7 from the 12 and the 1. So that means that the 1 and 12 are incorrect. So let's try the 2 and the 6. X times 6 will be 6x. X times 2 will be 2x. So 6x and 2x won't be able to give us this 7x, okay? So then we try the 3x and the 4, and it's like that. So what I've done there, I've just demonstrated for you there trial and error, right? Trial and error is a perfectly valid way to go about answering a problem as long as the number of possibilities isn't too much, okay? Like if we had like pairs, not just 1 and 12, 2 and 6, 3 and 4, but they went right down like this, it wouldn't be a good method because we'd be ages at it. But since there's only 3 possibilities, we can just go through those 3 possibilities rather quick, okay? And again, the nice thing about factorization is that we're going to be able to test this out. So remember, multiplying x by 4, x squared plus 4x, 3 by x, 3 by 4, 3x plus 12, x squared plus 7x plus 12. Brilliant. We get back to the start. Okay. I'm not trying to make a meal out of it. I'm just trying to give you a kind of nice warm-up type examples. Okay, so just take a moment. What I've written here below is the different ways that we can use to factorize that 15, and there are only sort of 4. Now, if we still found that none of these worked, well, then we would have to use the quadratic formula, which is the x is equal to minus b plus or minus square root of b squared minus 4ac over 2a. But we're not going to use that unless we have to, because that's quite long, right? And there's lots of, lots of places we could go. We could make mistakes with signs there. And so if we look at this list here, well, we can rule these ones out straight away, right? Because we don't have any minuses, right? Minus by minus will give us a plus, so that wouldn't be a problem. But we don't, this is always going to result from the sum. So if it was negative, then and this 1 and 15, it's just no way that we can get an 8 from that. So it has to be this one. It has to be the 3 and 5. So it's kind of like you get kind of quick at these, but don't rush this. Like, go through all the possibilities, but it might happen that you're able to discount a few of them, or even go for the most likely one first, if that makes sense, and save yourself a little bit of time. I'm going to be saying this again and again, but you got to think, like, imagine if we were sort of doing this question. Let me find it. Let's say we're doing this question here, and we jumped straight to that line, and we didn't write that line down first. This is the equivalent. Imagine you have a step of stairs or something like this. It's like taking 2 steps in one, and you can do it most of the time. It's no problem. But you know what? Maybe most of the time when you fall on your face, it's when you try to take 2 steps at one time, right? And you wouldn't believe the number of times as people make just silly mistakes that they shouldn't have made early on in questions, lose loads of marks, just because they wanted to save themselves a bit of time. How much time did you really save? I always think it's just best to proceed really sort of prudently, just take every single step and only kind of skip steps if you're like, if it's kind of ridiculous, right? Like if you're like, I totally don't need to, I can jump these 2 steps here or something. So, but in general, you don't really save yourself time from doing that. Okay, so another example. So just take a moment. Oh, this is why I had that poll thing, isn't it? So I don't know if we can sort of use it, but probably won't end up using this, but thought it could be kind of useful. So we have this 21 here, and the 21 could be 1 and 21, minus 1 and minus 21, 3 and 7, or minus 3 and minus 7. Now, each of these pairs, they multiply to give us the plus 21 because they have the same signs, but which of them add to give the minus 10? And as soon as I say it like that, it's obviously this one, right? So you see the way, even with a trickier example, once you're sort of being methodical, the way you got to lay it out, and you just start looking, you're realizing, okay, these pair of numbers have to multiply to this, they have to add to this. Now, this is made more complicated when you don't have a 1 at the start. Okay, so it's just a little trickier, but it'll take you a little bit more time just to spot the example. But once you lay it out properly, your eye goes straight to the answer, right? Okay, so let me now go to the next one. Okay, so here's just kind of quick ones. So this is clearly, oh yeah, I think I'm asking you here, like, for the first one, the question is which type is this? Is this a common factor? Is this the difference of 2 squares? Or is this a trinomial? So this has got like an x squared and a number. So this is clearly x squared minus 5 squared, which is x minus 5 by x plus 5, difference of 2 squares. Brilliant. You can use full stops in maths. It's like it's the end, Okay. So remember, if you have any questions, just like throw them in the chat. Okay, for this example here, it kind of looks like the previous example, and it kind of looks like the next example. It's not a trinomial because it needs that number at the end to be a trinomial, right? So we can't use separating brackets. And it looks kind of like difference of 2 squares, but it's not because of that x that's there, right? This has to be just a number, and this has to just be a variable squared, right? So this is just your standard x into x minus 25. So it's actually the first type, the common factor one. And then this one here is a trinomial. So just basically, so I say when you go to solving a maths problem, there's like basically 3 steps. There's the diagnosis stage, which is like, what kind of problem do I have? The first problem here was a difference of 2 squares. Second problem is a common factor. Third problem is a trinomial one. So that's the diagnosis kind of done. And once you've diagnosed, then you're like, okay, now that I know what it is, now I have to get the right method to go ahead and solve this. And by the time you're doing that type of stuff, you already have half the marks, and you can get super fast at this stuff, and you could actually go through the exam, and the exam's going to take you whatever 2.5 hours, and like just to get to the point of getting like half the marks, you could probably do in 45 minutes. You know what I mean? Because if you come along to every single question and you diagnose every single question and you pick the right method, and then you throw in some numbers, and then you're like, I'm tired of this question. I'm not doing any more now. You're probably going to get half the marks. Sometimes you even get like 7 marks out of 10 for just doing that. What really takes the time is that last 3 marks out of 10. That's what uses up like an hour, like over half the time in the exam. Like, so what I really believe in is kind of setting a base for yourself, right? Like knowing that you go into the exam, knowing for certain that you're going to be able to diagnose every question, that you're going to pick the right method, pick the right formula to do it, and get used to throwing in a couple of correct numbers and doing some couple of correct steps, and leaving unfinished work, and just knowing that no matter what happens, I'm definitely going to get 50%. Right. And then that's like that becomes your new starting point. Every single thing that you do after that is bringing you up. So it's very important to get this diagnosis and application stage going correctly. Okay. So this last one, x and x, two numbers that multiply to give me 25 and get to 24. Well, this is going to be 1 and 25. Okay. And we have a plus, we have a minus here. So we have to have different signs for the multiplication bit. And then we have this plus 24. So the larger of these two numbers has to be the plus. Okay, so maybe take a minute or so to have a look at these examples, just to sort of just quickly apply. I'll just give you like a minute or two to do these ones. I have plenty more examples after this. So maybe just do that for a minute, and then. Okay, so we'll just throw them out. So first one is a trinomial, right? So we know what method to use. Two numbers that multiply to give me 20, 1 and 10, sorry, 1 and 20, 2 and 10, 4 and 5. Clearly 4 and 5, everything is plus, so we're done. So then x squared minus 36. Well, 36 is a perfect square. X squared minus 6 squared, x minus 6 by x plus 6. This one here, 3x plus 12, so no squares, no trinomial. This is just going to be a common factor, 3 of x plus 4. And then this one here is a trinomial, so this will be my method, two numbers, x and x, and then two numbers that multiply to give me 5, and then add to give me 6 is like a 5 and a 1, okay? So you see the true speed, it's like really where people kind of get slowed down is sort of if you kind of bite off more than you can chew, right? It's sort of like if you just sort of proceed and then kind of like, what kind of problem is this? What kind of method do I apply? Okay, start with the right method, write down the pairs of brackets, x and x, and then you're always boiling it down to the piece of it that is the unknown piece where you can concentrate all of your attention. Okay, this is just making it easy for yourself and make sure that there's no individual step in this process that really exerts you, okay? Like that really is sort of tiring. Like everything is broken down into a trail of small little mini questions. Okay, so obviously when we come to doing the Leaving Cert exam and stuff like this, they're going to throw curveballs at you. This is like a baseball analogy, but it's like you can expect that they're going to they're never going to give you the questions in this neat way that you see sort of in the book. They're going to find a way to put a kind of a twist on the question that makes it kind of awkward. So I'm going to go through a few of those examples first. This first one here, this is what I kind of call like, well, let's just sort of, set everything up first in the way that we expect to kind of see it. So it's kind of like cleaning up a little bit, even before we do the question. And what I would do is, well, this is a trinomial. I'll just like rank it so I have that x squared term first, basically. And now you're like, okay, this is, pay attention to that feeling of relief, because the feeling of relief means that you haven't really searched your full brain yet, but you know that the answer is there somewhere and it's not going to be too exhausting. That's why you feel relieved, right? So we have to be prepared to do little bits of sort of tidying up before, before even launching into the question. Now we could do it. Now it's easy. It might seem like kind of a straightforward thing, but like from years of like marking exams, things like this, like these are the painful places you see people making mistakes, right? So we're done. It's like you're just watching people going, oh, why didn't you just make this little change? And the reason why they didn't was because they weren't sort of calm and collected enough in the moment. They kind of were just a bit nervous or something like that. And then they started trying to answer the question when it wasn't in a state to be answered, right? Okay, this one here is a bit weird because it looks like the difference of two squares, but it's got this x to the power 4 piece. So this is certainly x to the power 4 minus 4 squared. So this is almost the difference of two squares. And what do I say to this? Well, what do I say about this is that brackets are your friends. Okay, so you can always use brackets doing maths problems, and basically it just causes clutter, and maybe you make mistakes because you never want to write too many symbols on the page, because it just you can kind of get messy and can be a lot of clutter, as I said. But as soon as we write x to the power 4 as x squared, you see what we require for the difference of two squares is something squared minus something squared. And you see that we actually have that now. See, we actually have something squared. What's that something? X squared is the something that is squared. X squared minus 4, x squared plus 4. And now the question is, are we stopping? And it's like, could we go further? And yes, we can go further, because this one here is x squared minus 2 squared, right? So this becomes x minus 2 by x plus 2 by x squared plus 4. Now, a couple of other things that I'm going to say to you right now. The first thing is, like, when you're doing a maths problem, you might feel that you're not correct because you're not neat. You might have left a big blank space over here, or you might have bad writing and all this sort of stuff. That's what that's what maths is really like. When you see, like, in the book, someone's typed it, it's perfect. It's been written with great format and, not too many lines or something like this. This type of maths is after all of the rough work papers have been thrown in the bin and someone's writing down this sort of perfectly neat. Maths is kind of written kind of messily. And the other thing I'll say to you is that the examiners are well paid, right? Like, you don't need to present very sort of, as long as the information is there, the examiner will find it. So it shouldn't be so much of a concern to have things super neat. You know what I mean? Once it's possible to follow a line of logic to get to the solution, then it's a examiner's job to kind of find that. So don't worry about being neat. Now, obviously, don't make it impossible to find the answer there. But even if I was to do this work and say, you know what, I'm totally wrong. I'm going to scribble all of this out. I'm going to try a different method, blah, blah, blah. Actually, the second method is actually totally wrong. I was totally wrong. You still get the marks because the examiner has to look at the scribble out work and find yes, that even if you thought it was wrong, it wasn't wrong, you'll still get the marks. Okay. So don't worry about neatness. And the reason why I kind of say that is that sometimes we're doing a question and you might realize, oh, I have to do another line, and it's gone over to the other side of the page now. You can see people starting to kind of lose confidence because they think that they haven't, and basically that's not your problem, right? Is what I'm saying to you. Like, so your problem is to write down correct work, and it's the exam. And if that means, going back over here and writing the answer up here, and as long as it can be followed, then it's the examiner's job to find the marks. Okay, so this one here, for me, this is looking like the difference of two squares, right? And because I have an x squared term and I have a number, so it's kind of, and it has a minus sign. So it's looking like the difference of two squares to me. But the problem is that 24 isn't a perfect square, and that 6 is kind of annoying me. And now it's not really fitting neatly into one of those original boxes, which was just like common factor, difference of two squares, or the trinomial, which were the three cases that we were looking at. But who said that it had to fit into one of those boxes? And one thing that I always say to people when they're doing maths is, look, if you don't know what to do, just do something sensible to begin with. That 6 is annoying me. So I'll just take it outside brackets, and there it is, you see. 6 times x squared minus 2 squared. So this is like this is a more difficult, it's a slightly more difficult, but just because it's been kind of, difficulty has been compounded. What does that mean? Compounding means putting two things together. We put two methods together. This is not really more difficult. It's just two things. And if we're able to separate the tasks and we just do one thing that we can do, followed by the second thing that we can do, rather than trying to do the two of them at the same time. That's what these intermediary steps are doing here, right? That they're allowing us to separate out the work. This is a reason why factorization is such a useful thing for us, because it gives us the ability to be able to break problems down and just look at the pieces of them and answer those pieces in isolation. Incidentally, this question is similar. Like, see this one here, the way they ended up with 3 terms. It was a difference of two squares thing that ended up in 3 terms. But what happened was we got down to this line here, and then we realized we had to do the same thing again. So this is compounding difficulty. It's difficulty, but it comes from having to do something that we know how to do. We have to do it twice. We have to do the difference of two squares here, and we have to do it again. That's not really more difficult. It's just longer, okay? So we're breaking something that's into pieces, and as I said, okay. Okay, so this one here as well, I don't like this minus sign. So what I'm going to do is equals, I'm going to take a minus sign outside of brackets. See, it's exactly the same thing. See that 6 there? I took that 6 was causing me problems. I took it outside brackets. This minus sign is causing me problems. I'm going to take it outside brackets. What does it give me? It gives me an x squared term here. This 5x here, this becomes a minus 5x, and this becomes a plus 6. So all you're doing is you're rewriting exactly the same thing again. You're just flipping all the signs. And where that falls down is that there's no plus there, but the first term doesn't, you don't write down the plus, as we know, okay? So all we're doing is flipping all the signs. And now we're going to do the question, but we're just going to carry that minus and these large brackets down, and then we're going to have a look. See, this is what we need to be able to do. We need to be able to ignore everything that isn't exactly what we're doing at the moment. This is like tunnel vision. And most of the time, you say someone's tunnel vision, you mean it as you're saying something bad about them, right? But tunnel vision, when applied in the right situation, is also we just ignore all the stuff that's not important in this moment. So we're utilizing a tunnel vision skill in the right way, in the right moment. So nothing wrong with that, right? So now I'm just looking inside the brackets, and it may help you to use a multicolored pen. Like, it sounds kind of silly, but if something helps you, use it. So you can see now I've said now everything in green just pertains to this piece in the middle. And we have an x and an x, and then okay, so two numbers that multiply to give me a plus 6. And add to give me a minus 5. Now, it's a plus 6, so they have to have the same sign. So it's either going to be a plus and a plus or a minus and a minus. So we have 1 and 6. Yes, we can get 5 from that because we can have 6 minus 1. 2 and 3, yes, we can get 5 from that. 2, what is it? It's 2 and it's 3 and it's minus and it's minus. And then in the final line, you know, we would remove what we'll call like just extra brackets. You know, like sometimes you've just got extra brackets you don't need, so we'll just get rid of them. So this was an example of we're doing a trinomial, but we have this common factor thing first. Now, this kind of stuff really sort of catches people out, you know, as soon as there's like we're not using X anymore because it's just the way it works. You just get familiar with one, you know, when we're doing these problems, we see the X, we feel essentially once we can do any of these problems with X, we have to be able to do them with any other symbol you want to be able to put in there, right? If it makes you uncomfortable, you could always just say, okay, well, X is equal to Z, and then write it as X, you know what I mean? This kind of thing can't kind of catch you out, right? So I'm going to split these up. So it's exactly the same thing. Y and Y, two numbers that multiply to give me 10 and add to give me 7, 2 and 5. This one here, so I have, you know, Z squared minus 7 squared. So that's going to be, you know, Z, like Z minus 7, Z plus 7, and I'm done. So I'm not being intimidated by the fact that they have, I'm using the same kind of method, okay? So this one here, 8m squared plus 12m, it's not a trinomial, okay? It's not, there's no minus sign. This is not just a number. So this is not the difference of two squares. So this is common factor stuff. Let's just take out one common factor that we can see that's kind of easy. First of all, well, there's a 4 that goes into the 2m, like plus it's 2m squared plus the 3m. But there's also an m, so a 4m into the 2m plus 3. So now I can put the full stop. This has been factorized, but we can go further. We could also take out the m. Now we can't go any further, so we're done. Okay. Now this one here is a kind of an interesting one. Like we have something which is like kind of starts to maybe make us think that it's like a trinomial, but it's got like 4 terms and there's the b there and stuff for this. And this kind of one here is actually like it's like this one. Okay, it's like this one, or it's like this first common factor one. Let me show you why it is. I'm sure you're familiar with it, but you know, it can happen that you can have it. Now, this one is harder than your standard common factor. Let me show you. Let me show you why. So what I'm going to do is I'm just going to look at the first pair of terms and the second pair of terms. Okay. So this is going to be like an a squared plus the 3a. So we'll look at that, and then a plus the 2b plus the 6. And let me just like factorize these to begin with. Was this meant to be a? Did I make a mistake here? So this is going to be a into a plus 3, this first one, and this is going to be plus 2 in this. Sorry, I made a mistake when I did this. Let me fix this. Let me fix that now. That was supposed to be an A. Sorry about that. Okay. Then this is a 2 into a plus 3. Okay, so all I've done is I've taken the first pair and I've just done a simple factor is common factor on this, and the second pair and I've done a simple common factor on this one here. Now, remember what I say, right? So if we put brackets around something, we can consider that as a number. Now, this one here, let's say this could be 2 times, this could be a times 3 plus 2 times 3, right? Like that. So that would be 3 times a plus 2, right? Because that's a common factor. The 3 is a common factor in both. Well, between this term and this term, the a plus 3 is a common factor. And then we end up having this a plus 2 at the end, basically. This may have been not the best example to choose because it actually is, it could also be written as a trinomial, as it turns out. But what I'm saying is that sometimes you have these things with 4 terms, and they actually end up being, you just do that common factor approach, but you have to do it twice in a row. So it's another example of compounding difficulty. You have a difficult question because it's longer, not harder, really. Okay, and you just have to be not put off by having to take many steps to get to an answer. When those steps are like not in themselves hard, right? Like not as if you were to jump straight to the answer from the beginning, that would be hard, right? But if you're just doing like things that you know how to do, and you just have to do those things many times, then that's not really hard. It's just longer. And anybody who gets good at anything, that's sort of what they've done, right? They've taken, here's a hard thing to do. They've broken it down into a bunch of things that are easy to do, and then they just do them, and they just turn problems in like very hard problems into very sort of long problems. Okay, that's the technique, basically. Okay, so we have factorizing when the leading term is not a 1. So what we do here is we're going to be looking at this number here going, okay, well, this could be 1 by 4, or it could be 2 by 2. But this first one, well, this can be 2x by 1x. In this case, we only have one possibility. And then here we have to put down the brackets, start off with there's only one possibility to get to 2x squared. That's 2x and x, right? And then we just have to kind of like do sort of trial and error. So in here, I'm going to take like 1 and 4, or I'm going to take 4 and 1, or I'm going to take like 2 and 2, and I'm going to see which one of these combinations can do it. And trial and error is a perfectly fine method to use to solve problems, as long as the list isn't too long. Okay, so that's what I'm going to say with these ones here. What I've done here is I've basically listed out all the possibilities to begin with. And then, what we're going to do from there is we're just going to go through them. So let's try 1 and 4 to begin with. So I'll have the 2 times the 4 and the 1 times that will be an 8 and a 1, and it's not going to be able to give me a 6. I can't make a 6 from an 8 and a 1, and no matter if I'm adding or subtracting or nothing. So let me try the 4 and the 1. So the 2 times the 1, that doesn't work. The 4 times the x, sorry, I jumped ahead of myself. 2 times the 1 and the 4 times the x, this actually does work. Does it? 2 times 1 is 2. And then 4 times here. So this does work. And then there's a plus and a plus. Oh, no, it doesn't. Sorry. It does, yeah. But then the 2 and 2 works, is it? Does this and this not work too? That's weird. I've been just teaching maths too long today, so I think that's why I'm not seeing it. So, okay, so I can put a 4 here and a 1 here. And so I have 2x plus 4. And if you see something that I'm doing wrong, obviously, then don't be afraid to tell me. This is 2x squared. This is 4x. This is 2x. And this is 4. So that's 2x squared plus 6x plus 4. Okay, that's good. Okay. Again, we'll try this one here. So we've got obviously 3y and y. It helps when it's like, if this was 4y, then it could be 1y and 4y, or 2y and 2y, right? But it's 3y squared, so it's only these ones here. And this 2 can only be 1 and 2, or 2 and 1. So I put this 2 here. I put this 1 here. That's 3y times the 2 will be 6. 1y times the will be like a 6y plus a 1y. So that's that one there. And yeah. Okay, so now I get then this one here. Okay, so again, I have this -2 at the front. I want to make my life a little easier, so I'll take the minus outside brackets. And I'm going to keep that minus outside brackets the whole time. And now I'm just going to concentrate in on this like inner part here. So that's going to be, now if we have a look at that, that's going to be 2m squared. 2m squared minus 5m plus 3. So we have a 2m and an m. Okay, two numbers that multiply to give me plus 2m squared minus 5m plus 3. Yeah. So two numbers that multiply to give me a plus 3. So it's going to be, yeah, it's going to be 3 and 1 and minus. Yeah. Which ends up being minus and then 2m minus 3 and then m minus 1. So this kind of one here, it had m's. Okay, that's awkward. Normally we like x's. That minus at the beginning, we had to take that outside brackets to start with. And then we had inside the brackets, we had this other problem solve, and then it's just like a standard problem then. Okay, so let's spend the remaining 10 minutes then looking at some exam questions. Now, I'm not like, I'm not like I do in the normal lessons that I do throughout the year, I do all the exam questions. Right now, I'm not doing that for this purpose. The reason why I'm doing this is just to kind of show you that, like the level that you need to kind of get to, and just nice examples where we can sort of say, like, the methods that we've been talking about today can be used in the real thing to solve like kind of real questions. So this one here is like solve the equation x squared minus 3x minus 4 equal to 0. Solve means get values for x, okay? So we'll have to have x equals. In fact, we're going to have x equals, and we're going to have one answer, and then we're going to like x equals. We'll have two answers for x in this problem. But before we can do that, we have to factorize. So we have to factorize. When we have an equation, we always have this nice thing that we say like left-hand side, right-hand side. So I'm just going to keep the right-hand side is equal to 0 and just leave that. Just forget about that. Just set that aside for the moment. And then I'm just going to look at what we've been doing. So x squared minus 3x minus 4. So two numbers that multiply x and x. Now two numbers that multiply to give us a minus 4. Okay, well, that's interesting. So that could be 1 and minus 4, or minus 4 and 1, or it could be 2 and minus 2, or minus 2 and 2. So let's just go through the possibilities. 1 and minus 4, plus 1 and minus 4. X times minus 4, that's minus 4x, plus 1 times x minus 3x. Oh, looky, we're done. Sometimes it happens that you just, out of the four possibilities, it's 1 in 4 chance, right? So, we happened with our trial and error approach to hit on the correct answer in the first. So we needed this minus here, told us that this number and this number have to have different signs, okay? So we have to have different signs, and that would give us a minus. So that's why it has to be one of these possibilities. And then just which of these just add to me minus 3. So you see it's that one. You get very quick at it after a while. Okay, and now that's the first part of it done. Now, if we were to stop now, we get 5 marks out of 10. I want you to look at this. This is something that I really try to impress on all my students, right? Okay, so this is the marking scheme, and the marking scheme has this scale here, and you have this low partial credit, which is this 3, and this high partial credit, which is this 4. So basically, if you do this, you get a low credit. If you do this here, you get a high credit, right? Now, what some students think is that they think basically, in a black and white kind of way. They think like in maths, you're either right or wrong. So you're either going to get 5 marks or you're going to get 0 marks. And they might be doing a question and they might go, oh, I did that question wrong because I didn't get to the 5 marks. Or I can't do this question because I can't get to the 5. I can't get to the 5 marks out of 10. And so they don't do the question. And so they just don't get any marks. And you just can't do that. Like, you know what I mean? It's one of the times I get properly kind of frustrated. It's like, if you're not going to get 5 marks, definitely get somewhere in here. Absolutely get somewhere in here. Okay. Now, if we look at this, you see this step here to do that bit here without doing the extra bit is correct factors, you see? So we're already, forget about this. This bit is 4 marks out of 5. Now, I don't, you know what I mean? Like imagine you got what's 4 marks out of 5? Imagine you got that on every question. That would be 80%. 80% is an amazing result. Okay. So it's just something that happens. It's just something that you have to train yourself out of. Like, because maths is all about precise and precision and all that sort of stuff. Sometimes we get this black and white thinking kind of comes in where it's sort of like, oh, I can't do this question. If you can't do a question, definitely get somewhere. That might, and you wouldn't believe how easy it can be to pick up marks. Like you might have a question about a triangle, and you might have to go, well, that's a right angle. There you go, 3 marks out of 10 just for doing the time. The full answer might be lines and lines and lines and lines, and then you get down there and you get 10 marks out of 10. But sometimes you can get 3 marks out. You can get the low grade, low partial grade, and you should definitely be getting that grade instead of 0. Okay, it's not about, you just can't let. There's a phrase that you can remember: just don't let perfect be the enemy of good. Like, good is good, okay, and be good before you be perfect. You can't be perfect unless you're good first. Okay, so it's just something to bear in mind. Okay, so but let's just sort of maybe finish this question just because we're here. So we worked out that x plus 1 times x minus 4 was equal to 0. Okay, and the other thing I've been saying is, as soon as you put brackets around something, you're considering it as a number. Okay, so we have this number multiplied by this number to equal 0. Let's say we've got 2 numbers. A is a number times B equal to 0. If 2 numbers multiplied to give you 0, there's only 2 possibilities. Either A is equal to 0 or B is equal to 0. One of them has to be 0. That is not true with addition. If you add 2 numbers to be 0, well, this could be minus 2 and plus 2. It could be minus 10 and plus 10. There's infinite number of combinations from addition that can give you the 0, but from multiplication, one of them has to be 0. So that means that x plus 1 has to be 0, or x minus 4 has to be equal to 0. And then this means that x is equal to minus 1, and this is equal to x is equal to 4. Now, in order then to get up to this, now this is 4 out of 5. This is 5 out of 5. So in this case, it's sort of, the last step is kind of trivial, but at the same time, you know what I mean? You have to remember the method to get there, right? So, so the real guts of doing this question was the factorization. We'll talk about this though tomorrow, I think, more. Okay, now have a look at this one here. And this one here looks like quite an awkward type of question. And if we go back to the first types of questions I gave you, so these types of questions here were all basically ready to go. And then we had other questions here, I was calling them special cases, where you had to do a little bit of preparation before you were ready to go. You had to kind of tidy up a little bit before you're ready to go. That was also true with this example. We had to take that x to the power 4 to make that x squared to be squared. That was true with this example. We had to take the 6 outside. So sometimes we have to do some sort of, tidying work before we can actually apply a method, and before, so there has to be some sort of stuff. Now, this type of question here, what's happened is that this question has already been factorized, but it's useless to us, because what we need is we can't have combinations. We need to have one big starting point. So what we have to do is multiply out everything else, get back to the big long expression, work on that, and then factorize that one. Okay, so it already looks like, well, this has been factorized. It hasn't. It's been weirdly separated into different pieces which have been partially factorized, if that makes sense. Like, what this is like, imagine you had the number 24, and you'd say factorize 24, and you're like, well, that's 2 times 2 times 2 times 3. Okay, that's it, factorized. Good. Well, what if we said 24? We didn't give you 24. We gave you 10 plus 14. And we said that was, well, 2 times 5 plus 2 times 7. You see, this has now been factorized, but not in a useful way if we wanted to factorize 24. So we have to go, well, what's 2 point? This is 10, this is 14, 10 and 14 is 24. Okay, now we can start. Okay, so you have to kind of go backwards a bit. So let's, I'm just going to draw out my arrows. So this is going to be this times this, this times this, this times this, this times this. And then it's going to be this minus 3 times all of this, and then the plus 4. So it's going to be x times 3x, that's 3x squared. X times minus 4, that's going to be minus 4x. 5 times, that's 15x. Then 5 times, this is minus 20. And then minus, then 3 times x squared. And this is where people make mistakes. Oh, man, it's like they say plus 6. It's just crazy. It's because you've done so much work already. You just have to be careful. It's minus 3 times the x squared, minus 3x squared. Minus 3 times it's minus 6, okay? It's just a matter of concentration. You just start thinking about, what you're going to put on your toast like later that day, and you just lose the sign because it's almost done, Okay. So what I'm going to do now is I'm going to underline all the x squared terms. I'm going to underline in a different color all of the x terms. And now I'm going to underline in a different color all of the numbers. Okay, so let's just go through it one by one. 3x squared minus 3x squared, they're gone. Minus 4x plus 15x. That's it, is it? This is, oh, sorry, I made a mistake there. What I did there is called a sanity check. I just looked and I'm like, wait, is there no other ones? What's happening? And then I had to kind of go, sometimes you have to go back to correct the previous step, just a little small correction. Minus 4x and 15x is 11x. And then minus 20 and minus 6 is minus 26. Plus 4 is minus 22 is equal to 0. So this whole monstrous thing that we started with all the squares and so on, is just this little thing here. Now let's just start again. 11x minus 22 is equal to 0. Let's imagine this was our question instead of what we were given in the start. That's 11 into x minus 2 equal to 0. And what we have is two numbers multiplied together to give us 0. So one of them has to be 0. 11 is clearly not 0. So that tells us that x minus 2 is equal to 0. That tells us that x is equal to 2, and we've solved it. So you see, like, if you had been given this as the Leaving Cert question, you'd be like, this is a joke. Like, this is too easy. So what they did instead was they gave it to us in this elaborate way that we had to work on in the beginning carefully to get down to something. Now, that type of problem is the following. Let's say this is a street and you're here and you're looking in this direction and you can't see your way to the answer. Why? Because the answer is around the corner. You just can't see it and you don't know what to do. And my answer is, like, when you don't know what to do, just do something that makes sense. Take a step forward. It's not wrong. Take another step forward. And then you get into a position where you're like, I see it. So you don't know. I didn't know that this was going to, but I trusted that it did, because, the question has to be answerable in a few steps. Okay. And if we see here, if we did the multiplication fully correct, we would have gotten the high partial credit. So if I go back here, when we see that minus 3x times this plus 2 here, and then I started thinking about what I was going to put in my toast later, and I put down a plus, I just lost 5 marks out of 10 for that. So how much it's punished. So it's not too, I'm not trying to, we're going to stop now because it's just time, but I'm not going to, chastise you about, I'm just demonstrating how, like, once you're kind of it's just basically like, once you know what to do, or once you're doing something that makes sense and you're like, okay, I think I've nearly finished this hard thing that I was doing, then it's very easy to get kind of complacent then. And it's just in that moment of complacency, that you just miss a sign, and then you lose 5 marks out of 10. I mean, that is particularly cruel, this one, that it's such a drop for making that mistake with that minus sign. So, okay, yeah. Okay, so I'm going to leave it there. The same would be true for this example. You would just multiply everything out. I'm going to email you later on with a link to this call, plus a little homework assignment that you are free to do or not do as you choose. just something that goes over the stuff today, just to kind of, and then tomorrow at the same time, 5:30, I'm going to go through like solving some equations and things like that. So more algebra then tomorrow. So yeah, so thanks, and then I'll see you then tomorrow.